Hello and welcome back. Please subscribe to my channel if you like the videos and want me to keep making them. I need to improve the subscriber amount so I know they're going good, and give it a like as well. We're going to just summarize some of the stuff that we've covered and also add a little bit of new knowledge with that. When it comes to interfaces that we just looked at, so the payable interface test, and we have our functional interface here, our functional class. So we just have one method in it, so that's our functional one. With these, the biggest difference between implementation inheritance and interface inheritance is that there is tight coupling. So you could be in an organization working and you need to, every time that you inherit from the class or extend from that class, let's say, you need to, it automatically generates all of the methods that are there, the abstract methods, and you need to implement them every single time. So sometimes it's a case of having a bit more flexibility, but then Java is a bit more verbose with that. And then with interfaces, it kind of allows you a little bit more flexibility with this, because with Java 8 it makes programming with interfaces appropriate for almost all cases in which you would have used abstract classes. There's also an example of using things like private constructors, so then you don't need to instantiate an object. So an example of that is the math class, which I keep going back to, which is a really nice example. So the math class, I don't need to instantiate a new object for it. I can't, because it's a private constructor. So all you need to do is set your constructor to private, and then what it does is it basically makes sure that the client code isn't able to create a new object based on that class. So the math class is a good example. So if I go to the math class, so if I go to the math class, let's say .max, and if I go to the implementation of it, hopefully it brings it up. Open implementation. It's marked a final class, so I cannot, don't let anyone instantiate this class. It's a private instructor, but it has public static methods that can be used along with, we have used the max. So if I just go to max, let's go again. Here. So we have here our max, which is one of the overloaded methods with this. So this is our integer max, and it takes in 2 integers, and I presume the rest are here as well. Yeah, so then this is the long one, and I presume the other ones are up here as well. That's the absolute value, maximum float, and it shows you how it does the calculation, and then double as well. So that's an example of where within the code in the java.lang package, which we can see here, that the math class is declared as a final class, and it's private constructor, so you're not able to create a new object from it. So that's one thing. And the next thing then is when it comes to sharing initialization code and constructors, it's good also for private constructor is sharing the initialization code among classes other constructors. So you can use delegating constructors to call private constructors and share the initialization code. So you can have multiple constructors, as we know, because we can have also multiple methods, and they're called overloaded methods, and the other ones are overloaded constructors. And then we have another thing called a factory method. So a factory method is a public static method that creates an and initializes an object of a specified type, possibly of the same class, and then returns a reference to it. So we'll talk a bit more about design patterns and things like that another time. But when it comes to just superclasses can change, so can interfaces, but interfaces change less because the implementation isn't there. So if we look at payable, we have no implementation attached to this method. We've just declared it as an abstract, so it generally doesn't tend to change as often. So that's also another benefit of interfaces. So we looked at polymorphism from the beginning, and polymorphism was extensible and maintainable, and we used the keywords in inheritance as well. So we used super for inheritance. We didn't need to super the constructor for using a lot of this stuff as well, but we did override methods and we implemented our interfaces, but we extended our superclasses for inheritance. So there are keywords that are used, and they're the general main concepts of object-oriented programming. So we've come a long way. So there's also the demonstrating polymorphic behavior. So when the compiler encounters a method, and when that method call then is made through a variable, it determines if the method can be called by checking the variable's class type. So as we know from when we have an overloaded method, so with the math class, as we saw here, with this we have math max, and then it's got multiple different well, it's not going to work there because it's not within a, let's say here, math.max. And then you can see there's 4 different overloaded methods within that. So it's one of the key concepts within object-oriented programming. And then we have abstract classes, which aren't concrete classes, but you can't instantiate an object for it. So we use the employee one with this. And this was here, public abstract class employee implements payable. So it's implementing this interface. So basically, when you're creating a class, the planning is really important, because we want to have a good design when it comes to writing the code. And then the primary purpose of an abstract class is to provide an appropriate superclass for which other classes can inherit and thus share this common design. So here we have employee, which is, I keep referring to it as kind of a blueprint, but actually that's not a great word to use, but we'll go with it for the moment. So it's like a blueprint. It's like every class that inherits from this class has to have these data. So it has to have 3 strings. They have to have first name, last name, and final. In the commission here, commission employee, we do call the constructor. So we call the superclass's constructor. That's really important. We need to do that for it to work. I demonstrated in a previous video that if I was just to say gross sales and commission rate here and remove these, then this would give me an error to say, do you want this as protected, or do you want this changed to get first name and use the getters? And we don't want to do that, because one, we're accessing the data directly. We need to implement the principle of least privilege, and it's better designed that when you trace back a problem, that you're only looking at the getters and setters. So it's an easier place to focus in on where the problems are within the code as well, if it's running differently to expected. Abstract classes can sometimes constitute of several levels of different hierarchy. So we have the abstract class here for employee, but we can also have more abstract classes, and then abstract methods do not obviously provide any implementations, but within an abstract class they do not have to have abstract methods. That's an important one to remember. So we have an abstract method here, but the rest aren't abstract methods, just one. And then this must be overridden by the concrete methods. And again, there's no implementation with the abstract methods. Abstract superclass variables can hold references then to objects of any concrete class. They're derived from the superclass. And then polymorphism is particularly effective for implementing like layered systems. So the private constructors, like in the math class, prevents you from instantiating a new object of math. So let's give it a go. If I wanted to, within here, if I wanted to say math equals new math, it's going to say no. The constructor math is not visible because it's set to private. So our access modifiers dictate a lot of what we're doing within programming. So protected is going to raise some flags when it comes to superclasses and the super constructor. If you haven't instantiated if you haven't invoked the super class constructor and then also had those variables within the commission employee instructors. So here we have the super class variables, instance variables, also within the subclass. So that's really important. Otherwise it will just say change it to private or change it to the getter methods, and we don't want to do that. Not recommended for the moment anyway. And then we also have within the inheritance, a class implements a method describing various abstract methods with that a new class must provide. So an interface then also may extend one or more interfaces, and in the previous video we had a look at that because I used within the previous one, we used serializable, runnable. We had 5 different types that we could use, that we could implement from. So we have obviously payable here, and then there's comparable, runnable, GUI object, auto-closable, and comparable, runnable, auto-closable, GUI, and one other one, runnable. Yeah, anyway, we'll get to it later. But for the moment, we know that we can implement multiple interfaces, which gives it a little bit more flexibility, because when it comes to just implementing the interface for payable, then it has one method in it, and that's a functional interface, but then we can use multiple if we want to as well within one program. So we can use multiple and use, let's say, serializable, that was it. So a key disadvantage then of implementation inheritance is the tight coupling. So then we have to inherit and we have to use a lot of the methods that are within the superclass and override them and stuff like that. So just be careful of that, because it'll become very verbose very quickly if you have to override all of the methods from a superclass in a subclass, and then all of a sudden your subclass is huge and you haven't actually written any code in your subclass, but your superclass has all the code, which isn't good either. It's not very organized. So interface inheritance gives you additional flexibility by eliminating the tight coupling, but then it's a case as well as you must provide the implementation of the abstract classes within that. And last but not least, I think we covered everything, but the notion of the final methods and classes as well, that when we're implementing the final here, we have the final instance variables, and because they're final instance variables and they're also private, we can only get them, we can't set them because they're set to final. Okay, so that's it. We're going to move on to exception handling next. So that'll start the next video. Thanks for watching. Please give it a thumbs up if you liked it, and subscribe to the channel so I know you like the channel, and I'll keep making them then. Okay, thanks a million. Bye.